Hello, and welcome to something a little different. I have found myself in need of a timing circuit, or rather a delay circuit. What I need to do, and let me bring out this is the timing chart for the 46. Right now, the ready line is being constantly held low, which means that everything's instantly ready. Now this is fine with how slow we've been running the processor, but as it gets faster, it's not going to be as good. The main problem especially sits with the ROM, because the ROM's read time is kind of slower than a cycle would be when the processor hits the full speed of 25 megahertz. Because of this, I need to build a way to insert wait states into accesses. The wait state is exactly what it sounds like. By pulling ready high, it makes the processor wait an additional cycle. And if we keep it high and never let it down, it will stay locked in that cycle, in that read cycle or write cycle, which is a way to pause the processor, but that's a future project. So the goal I have in mind is to use the 74163, which is a preset binary counter, or presettable binary counter, because it says presettable right there. So the idea, yes, I actually am going to be drawing this live because I'm literally doing this as I go, is that we have the counter here. Goodness, my handwriting's awful tonight. And in that we would feed it on the binary number. So that's the count in. And when that count hits 0, we would then set that to the ready line. So the idea is that we when we're accessed, we would put a number into this using the load, and then once it hits, and that will pull the ready line high until the count hits 0. This works pretty well as such. There are a couple caveats. Obviously, the clock has to go into this. I'm explaining this very poorly because I don't know what I'm doing yet. And there's also 2 output lines. So we have basically 2 enable lines. And loads there. And both have to be active for the count to work and for the output to be enabled. So the rough idea I have is to tie both one of the enable lines and the load line to the address data strobe. So tie that to both of these. The reason why is that when it's low, which is if we go back to the timing sheet, only done at the very start of a memory cycle, so it indicates that the address data is valid. We would then load the count into the counter, and when it goes high again, we will then enable the counter, which will then enable the output and start doing the countdown. Now the only downside is this particular output here, which that's the carry output is an active high line, so we're also going to need to invert it to get the actual ready signal. So that's the plan. Yeah, that's the plan. That's what we got. We're doing this on the fly, doing it live. So have our usual power and clock board, which will work just fine, and even provides us an extra button, which I'll get to in a moment here. Our chips and the good old input board. So, and grab some various bits and pieces of patch cables and wires. So yeah, we're doing this one the old school way. I say old school, it's not old school. I mean, this is the thing I've been doing for everything. It's hardly old school when I'm doing everything in that style. Okay, so power, ground connection. And we're going to need the extra here, so power and ground. Okay. There. So that wires that up. So to start with, we have the chip. There we are. And of course we need to get the appropriate power and ground lines in. And I also have the inverter, but well, I just might as well talk about that now. So I also have this. This is a Zener inverter. You know, it was something I did ages and ages ago. Let me actually zoom in just a little bit so you can actually see this. Something I did as part of practicing my SMD soldering. Didn't go well. It was probably a little too small. But I have a couple of these just single gate inverters floating around. So, this is a good use for it. And I don't have a printout of the data sheet, but that's okay because it's pretty straightforward. Though, the very first one of these I made, I wired backwards. So ground to power, power to ground. And that's the only time so far I've ever let the magic smoke out. So yeah, don't wire these backwards. Bad things can happen. So yeah, there's your message of the day right there. Let's see, clear. I do not need the clear line set to anything, so we'll pull that to high. Clock, I need a longer. So, no. Wrong ends. Let's get the right ones. All right. So, come on, stay in there. I need new breadboards. Actually, let's double the length of this one. Yeah, I've recently found that the nice breadboards I bought to use for the build are terrible and basically don't hold pins worth a dang. So yeah, careful with your breadboards you pick to use, because I chose poorly, and I will be paying for that in the long term. All right, so next is the enable line. So we have two enable lines, so we want to keep one pulled high, so we will use the one that's there's two. There's this one and this one. We'll pull this one high. Yeah, because they're active high. I'm going to move that for the time being. And then the next two we're going to tie together, because that's going to be our active and okay, there we go. It's these two. So this is our address data strobe and our enable. So in theory, these lines should be nicely opposite of each other. So that in. That should be in. Okay. So mode enable, carry output. So something less long. So carry output will go into the input of the inverter, and the output of that will go into let's see, we need two outputs here. We'll have one output here for the inverter. So that will give us our nice active high. So that output there. And we also need a center one for just to show the count. Okay, so let's wire up the count lines. So these are backwards, annoyingly. So I need to, twist them all. And yeah, believe it or not, I don't have 4-pin cables. Maybe I should. I don't know how often I'd be needing them, but you never know. 4 pins might be useful. Okay, so that's there. And lastly, we need a slightly longer set of cables, I think, here. So that's one. Problem is I have like long cables and I have medium long cables, but I need something slightly longer than the medium and shorter than the long. And I'm doing it backwards anyways, so there's one. Yeah, okay. I was hoping to not need to patch these, but I guess I do. Okay, 1, 2, 3, and 4. So lastly, we have the clock, which will just, it goes, I'm off by 1 on my inputs. Okay, clock goes there. And then lastly, we have the button, which is going to be standing in for the ADS line. So, what's that? We'll put this onto the active high output and slide that around to here. Okay, well, let's see if this actually works, shall we? Load. Okay. 4, 5, 6. Okay, well, that's good. Well, at least partly good. Okay, I looks like I screwed the inverter up. Let's just do a quick test. So pull this to ground, it should go at high. So pull this high, it should go to ground. All right. Okay, that feels like there's a loose connection somewhere. Okay, that's a bit better. So I will then connect that to there. All right, so cycle the clock again. Now that was interesting. And it's loose again. All right, there we go. That's what we want to see. So, and right now everything's 0, so if I load it, it should go to 0. Okay, so let's put a number on here. Load. Okay, well that's not working right. You know what? Does load require it to be active? Yeah, the timing right here. Load does not. Oh, I know what I'm missing. I need to hit load and clock it. All right, that's nice. Load clock. So let's put this onto the okay, you know, this I think can work. Okay, yeah, I think this would work. So if I have 15 here, I want to put this back to memory for a second because that's a question. Hit load. Okay. What did I do wrong? Oh, I moved the wrong pin. So if I clock this, let go. Okay, that's what I want to see. So that's immediately there. So for when it's at 15, that basically is 0 clocks. So the idea is that we'd have the clock constantly running. So it would go low, and then as soon as it goes up, it's off. Yeah, I think this will work. So I think this works as the timing circuit I need. Now, I will want to do one last test here. I'm going to take this off and tie it to ground. I want to verify that. That's a little disappointing. Now the question is that okay, see, that's a little disappointing. Because the idea is that it will get, let's just, like this. Stop, okay. This is where it's going to be. And it would then, of course, disconnect everything. You know, it says ready, it finishes, it moves to the next cycle. We want to know that we can disable the output. And I was hoping that would work. But that may not be good enough. So, let's temporarily take that out and put that onto low as well. Oh, that's interesting. But if we tie this to low, okay, no, that's not what I thought it was. That's just whatever that looseness is. Or is it? Oh no, it disables that output. Oh, let me do it this way to make it easier to see. So being grounded disables that output. So what I really want So I think what I want is I want load and these two tied together like this, and then tie this one to low. Is this going to work? Because that's not tied to anything, so we'll tie that high. So they're both there, so tie that to high. That's what we want to see. I'm fairly sure that delay is caused solely by this chip and something's just bad with my wiring. I'll keep telling myself that until I prove it otherwise. Yeah, see, there it goes instantaneously. So yeah. So turning that low, but disabling this turns the output off. So that's great. That's great. That means the enable T. I don't know why it's called enable T, enable P. It doesn't explain it. If we tie that to the chip select, the same one that selects the chip, possibly through an inverter, definitely through an inverter, the logic that selects a certain device to access would also select this to output. So ADS would be high. Same time we get this cycle. Oh, right. Let me just change that a bit. That's what the... Okay, there we go. So yeah, what we would have is it'd be like this. So that's in there. The chip select would come on, enable the line, which would then, so this is outputting, but we're in ADS, so it doesn't matter. So ADS is cycled, we get one clock cycle, and then as it comes off, it's already disabled. Okay, I think this will work. I think this is a valid way of setting my clocks. Yeah. I think this arrangement will work. So fantastic. So we have a time, the rest state circuit put together. So hopefully I won't need it. I'm going to need it. As I said, the read times for the ROM just aren't good enough. But otherwise, yeah, that's its project today. It's just this wonderful little design. But it works. So that's awesome. Nice. And I jostled whatever loose again. Knowing me, it's probably just the actual chip itself. I didn't exactly put together very well. Alright, but there we go. That is it. And it works. So I think that's going to wrap me up for this particular episode. Would I call this a bonus episode? I don't know. But yeah, that wraps me up. I think that should be good. And there we are. All right. I just couldn't leave you hanging on that note. So here's the circuit in situ. And it works perfectly. Worked perfectly the very first time. Though admittedly, I remembered I had a free gate up here. And I just reset it. Oops. Oh well, it still demonstrates it. But yeah, I had a free inverter right there, so I just used it for this time. But yeah, so you can see just how fast everything's been going right now. We're at full speed. But if I dial this down, you can immediately see this how the system slows down. And you can tell just by the way the lights flash. And if I dial the clock down even lower, it becomes really obvious. Because each time it flashes is when it goes into new opcode, or new read. So if I kick this back up to full, there you go. So yeah, it works perfectly. Exactly the way I intended to first try. So, yeah, sometimes that happens. Don't know what to say about that, but it worked.